Good morning, everyone. In the previous class, we were discussing this problem, the last problem. Language over the alphabet 0, 1, strings such that number of ones is even and number of zeros is a multiple of 3. Okay, so we were discussing this particular examples. There must be even number of ones and number of zeros must be a multiple of 3. So already we considered few examples. Okay. So in today's class, let's see how to develop the DFSM for this particular example. Okay. So we need 6 states, okay, representing 6 combinations with respect to number of ones and number of zeros. So first state, I'm going to call it as, okay, first state, let's say it is representing the state where you have even number of ones, number of ones are even, so even ones, and the number of zeros are such that remainder is 0. So when you divide the number of zeros by 3, you get remainder as 0. Okay. Then the next combination or the next state is representing the combination where you have odd number of ones and number of zeros are such that remainder is 0. So number of ones are odd. Okay. Next combination, copy this everywhere. Later I'll modify. So this state is representing even ones and remainder is 1. So number of zeros divided by 3 gives remainder 1. So here you have, this is nothing but odd number of ones, remainder is 1 when divided by 3. So here even 1 Reminder 2. Okay. Then odd one, reminder 2. So odd one, reminder 2. Okay. Now, so let me number these states also. So let me call 1, 2, 3, 4, 5, and 6. Okay. 1. Okay. State 2. Then you have state 3. State 5. State 6. Okay. Now, now you need to tell me among these states which one is the initial state, which one is the final state, which one is the initial state, and which one is accepting state. Can you tell me which one is the initial state and which one is the accepting state? Yes, give your answer. Yes, tell me which one is the initial state here and which one is the accepting state. Yes, give your answer quickly. So state 3 is the accepting state. Why state 3 is accepting state? What is the logic? Yes, Anvit. Why state 3 is the accepting state? So language is over 0, 1 such that there must be even number of ones and number of zeros must be a multiple of 3. Must be a multiple of 3. Okay. So if you consider a sequence of ones and zeros, let's say you have 1 0 1 0 1 0 1. Now, whether this string belongs to the language or not, 1 0 1 0 1 0 1, whether this string belongs to the language or not. Just tell me whether this string 1 0 1 0 1 0 1, whether this belongs to the language or not. Just give your response quickly. So this string belongs to the language. Why? Because how many ones are there? You have 4 ones. You have 4 ones. And how many zeros are there? 3. So number of zeros are 3. When you divide 3 by 3, remainder is 0. That's how you check whether number of zeros is a multiple of 3. So you have 4 ones and 3 zeros. So even number of ones and number of zeros is a multiple of 3. That's why it belongs to the language. Whether this string 1 0 1 0 1 0 1 0, whether this string belongs to the language, whether this string belongs to the language. Let's give your answer whether this string belongs to the language. No, this string doesn't belong to the language because you have even number of ones. Okay, 4 ones are there, but number of zeros are 4, which is not a multiple of 3. Okay, so 4 zeros are there. When you divide by 3, what is the remainder? 4 by 3. Remainder is 1. That's why this is not a string which is a part of the language. Okay. Next, I'll consider one more. Okay, so this 101010 100. So whether this string belongs to the language, again this string also not a part of the language. Even number of ones are there, but number of zeros are 5, which is not a multiple of 3. So 5, when you divide by 3, what is the remainder? Remainder is 2. That's why it doesn't belong to the language. Number of zeros divided by 3 must give a remainder of 0. Then only it may belong to the language when there are even number of ones. Okay. Now, now with this knowledge, tell me which one is the initial state, which one is the accepting state here in this particular TFSM. Okay. Among these states, which one is the initial state, which one is the accepting state? Yes, make it fast. Yes, give your response quickly. So now you have understood, we considered many examples. Okay, so you know when a string belongs to the language and when it doesn't. So with this knowledge, you can answer out of these 6 states, which one is the initial state and which one is the accepting state. Yes, make it fast. Make it fast. Yes, tell me quickly which one is the initial state and which one is the final state. So one is the accepting state. One is the accepting state. Yes, one is representing even number of ones and remainder 0. So this is the combination which is representing the strings which are a part of the language. Then now initially you know that you don't have ones, you don't have zeros. Okay, in the initial state you have not read anything. Initial state is representing the state where you have not processed any of the symbols from the input string. That means you don't have ones as well as you don't have zeros. That means you have 0 ones and 0 zeros. 0 ones are nothing but even number of ones. 0 zeros are nothing but a multiple of 3. 0 is a multiple of 3. 3 into 0 is 0. So 1 itself is the initial state also. So initially you don't have ones, you don't have zeros. You have 0 ones, 0 zeros. 0 ones are nothing but even number of ones. 0 zeros are nothing but zeros which are a multiple of 3. So that's why the state 1 itself is the initial state. State 1 itself is the initial state. Okay. So this is the initial state as well as the accepting state. Initial state is marked by an infinite arrow. Now, now, okay. Now you need to add different transitions into this DFSM. Okay. So in state 1, if the input symbol is 0, to which state you need to make a transition? Tell me quickly. State 1, input symbol is 0. State 1, input symbol is 0. To which state you are going to make the transition? State 1, input symbol 0. To which state you are going to make the transition? Yes, tell me. State 1, yes, give me the answer quickly. Okay. State 1, input symbol 0 here. To which state you need to make the transition? So state 1 input symbol 0, you're going to make a transition to state 3. Okay, state 1 input symbol 0, you make a transition to state 3 because in state 3 reminder is 1. So when you have single 0, remainder is 1. 1 divided by 3, quotient 0, remainder 1. That's why number of ones remain as it is, number of zeros are increased by 1. That's why remainder is changed from 0 to 1. Okay, so that is the transition for input symbol 0. That is the transition for input symbol 0. Okay, now in state 1, if the input symbol is 1, in state 1, if the input symbol is 1, what transition do you need to make? In state 1, input symbol 1. State 1, input symbol 1, what transition you need to make? So you're going to make a transition to state 2. Yes. So you'll be making a transition to state 2. And the input symbol is 1. And the input symbol is 1. And the symbol is 1. You make a transition from state 1 to 2. Okay. Now, now let's say you are in state 2. For state 2, what transition you need to make on 0? Yes, for state 2, what transition you need to make on 0? For state 2, you need to make a transition to state. You need to make a transition to. So you need to make a transition to state 4. So you need to make a transition to state 4 on 0. On 0, you will make a transition to state 4 because as you can see in state 2, remainder 0, and one more 0 arrives, remainder becomes 1. Okay. Then in state 2, on 1, what transition you need to make? State 2 on 1, what transition you need to make? Let's make it fast. State 2, input symbol is 1. To which state you need to make the transition? State 2, input symbol 1. What transition you are going to make? Yes, tell me. State 2, input symbol 1. What transition you are going to make? So you'll be making a transition to state 1. Okay, you'll be making a transition to state 1. Yes. Okay, like this. So in state 2, odd number of ones, remainder 0. So when one more 1 arrives, zeros remain as it is, remainder 0, but number of ones become even, from odd to even. That's why there is a transition from 2 to 1. Okay. Now let's say in state 3, if the input symbol is 0, what transition you need to make? In state 3, if the input symbol is 0, what transition you need to make? State 3, input symbol 0, what transition you need to make? So state 3, input symbol 0, you're going to make a transition to state 5. Yes. So input symbol 0. So you're making a transition from 3 to 5. So when input symbol is 0, reminder changes from 1 to 2 when number of zeros are increased by 1. Okay, in state 3, if the input symbol 1, what transition? State 3, input symbol 1, what transition? Can you tell me? State 3, input symbol 1. State 3, input symbol 1. So there is a transition to state 4. Okay, state 3, input symbol 1. There is a transition to state 4. Yes, even number of ones become odd number of ones. Now we consider state 4. So in state 4, if the input symbol is 0, what is the transition? In state 4, if the input symbol is 0, what is the transition? The transition to state 6. Yes. The transition to state 6 on input symbol 0 and on input symbol 1. On input symbol 1, there is a transition to state. There is a transition to which state? There is a transition to state 3. There is a transition to state 3. So odd ones become even ones. Then in state 5, if the input symbol is 0, if the input symbol is 0, what is the transition? Now tell me, in state 5, input symbol is 0, what is the transition? State 5, you are in state 5 now. Let's say if the input symbol is 0, what transition you are going to make? State 5, input symbol 0, what is the transition? Tell me quickly. State 5, input symbol 0, what transition you are going to make? So you will be making a transition to state 1. Yes, you will be making a transition to state 1. Okay, like this. So on 0, you are making a transition from state 5 to state 1. Okay. Now in state 5, if the input symbol is 1, in state 5, if the input symbol is 1, what transition you are going to make? State 5, input symbol 1, you are going to make a transition to state 6. Yes. We are going to make a transition to state 6 on input symbol 1, state 5 to state 6. Okay. Then let's concentrate on state 6. Now in state 6, if the input symbol is 0, what transition you are going to make? State 6, input symbol 0, what transition you are going to make? Yes, from state 6 to state 2. So you'll be making a transition from state 6 to state 2. Yes. Okay. Now in state 6, if the input symbol is 1, what transition you are going to make? In state 6, if the input symbol is 1, you are going to make a transition to state 5. Yes. So you'll be making a transition to state 5. Okay. So this completes the DFSM for the language where you have even ones and number of zeros is a multiple of 3. So this is the DFSM. So you can consider some examples. Let's consider one example. 1 0 1 0 and 0 1. So here you have 4 ones and you have 3 zeros. That's why it belongs to the language. So first one, there is a transition from 1 to 2. Next you have 0. There is a transition from 1 to first 1, there is a transition from 1 to 2. Next 0, there is a transition from 2 to 4. Next 1, there is a transition from 4 to 3. Next 0, there is a transition from 3 to 5. Next 1, there is a transition from 5 to 6. 0, there is a transition from 6 to 2. 1, there is a transition from 2 to 1. So after reading the entire string, you are in state 2 or state 1. After reading the entire string, you are in state 1. So state 1 is an accepting state. That's why this string belongs to the language. Okay. So that's why this string belongs to the language. Okay. So I hope all of you understood this. So these are some of the examples. So if you go through the online resources, you'll find many more examples. So it is better if you practice more and more examples. Okay. Now I think I've not done the theory of this DFSM. Let's see the formal definition of a DFSM. So deterministic finite state machine M. So DFSM is represented by M. M stands for machine. So it has 5 tuples. First one is K. So K is a finite set of states. Sigma is nothing but the alphabet. S is the initial state. A is set of accepting states. Delta is the transition function. Okay, delta is the transition function. So if I consider this example, so here, what is K? You know that there are 6 states. So set of these states is nothing but K. Then sigma is nothing but alphabet. So you know that language is over the alphabet 0, 1. So sigma is nothing but 0, 1. What is S? S is nothing but the starting state, which is nothing but 1. A accepting states, which is again 1. We have only one accepting state for this particular DFSM. Then delta. Delta is nothing but the transition function, which we can define. So you know already transition function here. So which is represented by delta. Okay. Let's So here delta is nothing but, so let me just explain. Okay, so here, so delta of 1, 0. That is, you are in state 1, input symbol is 0. So delta of 1, 0 is nothing but 3. So in state 1, input symbol 0, there is a transition to 3. Similarly, delta of 3, 0 is nothing but 5. State 3, input symbol 0, make a transition to state 5. Similarly, delta of 2, 0, transition to state 4. 4, 0, transition to state 6. So that is nothing but delta, the transition function. Okay, transition function. So that is so that is the definition of DFSM. So there are 5 tuples: K set of states, sigma alphabet, S starting state, A set of accepting states, then delta is the transition function, which is defined from K cross sigma to K. That is, delta takes one state and one input symbol, and it gives another state as the output. That is, if I consider this example, state 1, input symbol 0. What is the next state? 3. That is nothing but delta. The delta of 1, 0 is 3. So it takes K cross sigma. K is nothing but state. Sigma is one of the input symbol. Then it gives another state as the output, which is delta. Then configurations. So configurations of DFSM. The configuration is capturing two things. One is the current state, and another is the input that remaining to be read. Okay, configuration captures two things. One is the current state, another is the input that is remaining to be read. Okay, so let's consider one example here. You will understand what is configuration. All of you have the idea of configuration actually. So, initially you are in state 1. State 1. Okay, 1. Then input is let's say input string is 101010. Okay, don't confuse between state and the symbol. So here this is representing state and next one is representing the string. Okay, this is nothing but the configuration. So initially you are in state 1. This is the input that is remaining to be read. So this is the initial configuration. Then this configuration yields one more configuration by consuming one of the input symbols. So which is the first input symbol? 1. Input symbol is 1. First input symbol is 1. So in state 1 input symbol 1, we make a transition to state 2. So 2 comma, what is the remaining input? 0 1 0 1 0. This is the remaining input. So one configuration is giving another configuration. Okay. So similarly, in state 2, by consuming 0, you get another configuration, which is nothing but state to 0. Go to state 4. So the next configuration going to be 4 comma 1010. So that is nothing but the configuration. So it captures two things: current state and the input that is remaining to be read. So that is configuration. So transition function already explained. Okay. Then yields as I told. So one configuration yielding another configuration. So this is called as yield relation. So you are in this configuration. So by using the transition function delta, you get this configuration. That means one configuration is yielding another configuration. So that's about yield. Okay. Okay. So that much is. Then you have computation. Computation is nothing but a sequence of configurations. So this is the first configuration, second configuration. If you go on writing like this, you get the final configuration where the remaining input will be epsilon. Because in each step you will be consuming one symbol at a time. So you consumed first symbol, you got this configuration. If you consume first symbol here, you'll get another configuration like that. If you go on consuming one symbol at a time, at the end, in the final configuration, no symbols will be remaining. That means input remaining to be read is epsilon, which is the final configuration. So that sequence from the initial configuration to the final configuration is called as computation. Okay. So that much is enough in theory. Okay. Next, so we discussed a lot about deterministic machines. So just remember, what is DFSM? It has 5 tuples: K, sigma, S, A, and delta. You need to know what is configuration. Configuration captures two things: current state and the input that is remaining to be read. Then yield. From the one configuration, you get the next configuration, that is yield. Then computation. Computation is nothing but sequence of configurations from the initial configuration to the final configuration. Okay, I hope all of you understood everything. Okay, now non-determinism. So till now we were discussing determinism or deterministic machines. Next we are going to discuss non-deterministic machines. So what it means is we could guess and our guesses would lead us to the correct answer. So in deterministic machine we were not guessing anything. Okay, so it was deterministic. There was no confusion in DFSM. For one state, for one symbol, there is only one possible transition. Right. Consider this example. For state 1 on input symbol 0, you have only one transition. That is from 1 to 3. For state 1 on input symbol 0, you don't have multiple transitions. Similarly, for state 1 on input symbol 1, only one transition. You consider any state and any input symbol, there is only one transition in DFSM, but in NDFSM, it's not like that. For one state on one input symbol, there is a multiple transitions. That's why it is called non-deterministic. That's why we need to guess which transition to follow. And our guesses would lead us to the correct answer if there exists a correct answer. So, then definition of an NDFSM. So, definition of an NDFSM. So again, there are five tuples, but now we have k sigma delta is the notation of delta. It is different than that of DFSM. Then S comma A. Again, k is the finite set of states, sigma is the alphabet, S is the starting state, A is the set of accepting states. But delta is not a transition function, it's a transition relation. Okay, so it is a transition relation. So it is from K, that is the current state where you are right now. That is next what you see, one of the input symbol, or it can be epsilon. That is without reading anything also you can do the transition. And output is nothing but where you go, the next state. This is a major difference between DFSM and NDFSM with respect to transition. There you have transition function delta. Here we have transition relation delta. Transition function is from K cross sigma to K. Here it is from K cross sigma union epsilon to K. So one epsilon is added. The input symbol can be one of the symbols in the alphabet, or it can be epsilon. Okay. Then accepting by an NDFSM. So M accepts a string if and only if there exists some path along which W drives M to some element of A. Okay, W drives M to some element of A. Okay. So if there is a path along which W drives M to some element of A, then accepted. Otherwise, it is rejected. Okay. Then, so this example clearly explains what is non-determinism. So here see, from Q naught, there are three competing moves. There are three competing moves. That is, either you can make a transition to Q1 without consuming any input symbol, or you can make a transition to Q2 by consuming A, or you can make a transition to Q3 by consuming A. So these three are competing with each other. Let's say you are in state Q naught and the input symbol is A. Now with the input symbol A, you can make all three transitions. The first option is you don't consume A at all and you make a transition to Q1. Second option, you consume A and make a transition to Q2. Another option, consume A, make a transition to Q3. Now which one you need to follow? That is the confusion. That's why you need to guess. That's why this is non-deterministic. Okay, I hope all of you understood what this non-determinism is. Right? Any doubts? Any doubts in this? Non-determinism is, tell me. Yes. Understood what is non-determinism? Any doubts in this? Yes, please tell me. Understood what is non-determinism? Any doubts? Yes, please. You need to speak. Any doubts in non-determinism? Yes. Is it clear to you? Is it clear to you? Yes. Others, please respond. Is it clear to each one of you what is non-determinism? Understood the difference between determinism and non-determinism? Okay. So just put one message also. You are thinking this much. I don't understand. Okay. Okay. Let me call the attendance. Okay. Sushmita,
Present, sir.
answer attendance. Sushmita,
Present, sir.
yes, Sushmita. Sushmita, absent, I think. Okay. Others,
Present, sir.
others,
Present, sir.
others. Ishwarya,
Present, sir.
Ishwarya,
Present, sir.
Ishwarya. Akshata,
Present,
Amal,
sir. Present.
Amal, Anvit,
Present, sir.
Present, sir.
Anvit,
Present, sir.
yes, once again. Let me call once again. Yes, Sushmita,
Present, sir.
others.
Present, sir.
Ishwarya,
Present, sir.
Akshata,
Present, sir.
Amal,
Present,
Amal,
sir.
Anvit,
Present, sir.
Present, sir.
Archana,
Present, sir.
Archana, Ashika,
Present, sir.
Ashwath,
Present, sir.
Ashwath, Atufa,
Present, sir.
Aisha, Aisha, Bhakti, Bhakti,
Present, sir.
Chirag, 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 Hariprasad, Hariprasad,
Sir,
Harshit,
present sir.
Present, sir.
Ibrahim,
Present, sir.
Kaushik,
Present, sir.
Hazi,
Present sir.
Anisha, Anisha, Mohit, Mohit,
Present, sir.
Lavanya,
Present, sir.
Faizan,
Present sir.
Aik,
Present, sir.
Hisham,
Present, sir.
Aulya,
Present, sir.
Nida,
Present, sir.
Pooja,
Present, sir.
Prajwal,
Present, sir.
Pranav,
Present, sir.
Prasad,
Present, sir.
Prashanti,
Present, sir.
Pratiksha,
Present, sir.
Shifa, Shifa,
Present, sir.
Rohan,
Present, sir.
Rohan, 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 Roshni,
Present, sir.
Sahana, Sahana, Hi Niketan, Sangeerth, Sangeerth,
Present, sir.
Shifa, Shifa, Aranya,
Present, sir.
Shrestha,
Present, sir.
Chaitra,
Present, sir.
Sriraksha,
Present, sir.
Shweta,
Present, sir.
Siddharth,
Present, sir.
Sneha,
Present, sir.
Surya,
Present, sir.
Saurav,
Yes, sir.
Srilal,
Present, sir.
Srijit,
Yes, sir.
Suman,
Present, sir.
Sumant,
Present, sir.
Puneet,
Present, sir.
Sushma,
Present,
Sushmit,
sir.
Present, sir.
Sushmita, Varshita,
Present, sir.
Varshita,
Present,
Hima,
sir. Present, sir.
Hima,
Present, sir.
Ida,
Present,
Altamash,
sir.
Altamash,
Present, sir.
Amrin,
Present, sir.
Bashiruddin, Bashiruddin, Tanya, Tanya,
Present, sir. Present, sir.
Rizwan, Rizwan, okay, okay. So, under this non-determinism, we'll consider few examples. So, the first one is optional substrings. Optional substrings. So, see now with the NDFSM, you can develop the finite state machine very easily compared to DFSM. Okay, so you'll understand how with examples. So now consider the first one. L is equal to W belongs to A comma B. W is made up of an optional A followed by A followed by 0 or more B's. So W is made up of an optional A followed by A followed by 0 or more B's. See here, this is the NDFSM. Okay. So the first one is optional A. That is either you can have epsilon or A followed by two A's followed by 0 or more B's. Okay. So this is the example for NDFSM where you have optional A at the beginning followed by two A's followed by 0 or more B's. Okay, I hope you understood this example. Any doubts in this? Any doubts? W is made up of an optional A followed by A. See, now you know that this language is over the alphabet A comma B, but still you have not defined the transition for Q naught on B. Similarly, you have not defined the transition for Q1 on B. Similarly, for Q2 on B. Similarly, for Q3 on A. Okay, so you need not define all the transitions in NDFSM. You define only the required transition. If suppose you encounter symbol B in state Q naught, that particular transition is not defined. That means your NDFSM halts. Okay, it is not going to proceed further. It halts, and if NDFSM halts means your input string is rejected. That's it. So if suppose in state Q naught you encounter B, that means string has to be rejected. Okay. So I hope all of you understood this. So here, see, in state Q naught, there are two competing moves. Either you can make a transition to Q1 by consuming A or without consuming A. That's why it's it's up to you to decide whether you need to follow this epsilon transition or you need to follow the transition which consumes a A. Okay. Then, so here we have the components of this NDFSM. So K, how many states are there? 4. Q0, Q1, Q2, Q3. Sigma is nothing but A comma B. Delta we have defined below. S starting state is Q0, accepting state is Q3. Then delta. So you know what is delta. Q0 on A, there is a transition to Q1. Q0 on epsilon, there is a transition to Q1. Q1 on A, there is a transition to Q2. Q2 on A, there is a transition to Q3. Q3 on B, there is a transition to Q3. This is nothing but delta. Okay, this is nothing but delta. So this is the NDFSM for accepting the language over the alphabet A comma B with optional A at the beginning followed by two A's, which is followed by 0 or more B's. Okay, so I hope all of you understood this example. Okay, next, multiple sub languages. So language or the alphabet A comma B where W is equal to either ABA or cardinality of W is even. There are two components. So either W is equal to ABA or cardinality of W is even. Okay. Now let's consider this. So here, so this part corresponds to ABA. So either W should be equal to ABA or it must be of even length. So both are covered here. So see, if W is equal to ABA, you follow this branch. Otherwise, if W is of even length, you follow this branch. Okay, so I hope this example is clear to you. That is, without consuming any symbol, you can make a transition to Q1 as well as Q5. So you'll make a transition to Q1 when W happens to be ABA. You make a transition to Q5 when W turns out to be of even length. Okay. So here, instead Q5, you have. So Q5 is the accepting state. So I have not read anything. Initial length 0, length 0 is even, that's why it is accepted. Later 1, 2, 3, 4. So every time you are in state Q5 means string is of even length. Okay. So here the states are Q0, Q1, Q2, Q3, Q4, Q5, Q6. A comma B is the alphabet. Q0 is the initial state. Q4 and Q5 there are two accepting states. Delta you can define easily. Q0 comma epsilon Q1, Q1 comma A Q2, Q2 comma B Q3, Q3 comma A Q4, Q0 comma epsilon Q5. See, there are two transitions on epsilon for Q0. Q5 comma A Q6, Q5 comma B Q6, Q6 comma A Q5, Q6 comma B Q5. So this is the NDFSM for this particular language. So any doubts in this? Please let me know if any doubts. Any doubts or everything is clear to you? Yes, let me know. Yes, any doubts or you understood everything? Yes, is that clear to you? Is this clear to you? This example, the last example, what I was discussing, is it clear to you? Yes, give your response immediately. Yes, is that clear to you? The last example, say something. Okay, so here, so this is, see how simple this is with the NDFSM. If you had to design DFSM, how much complicated it will be, because we have to consider so many cases, many transitions, so it will be more complicated. But NDFSM is very simple. Okay, so you have designed the FSM for the complicated language, that is missing letter language, easily by using NDFSM. Okay. Yes. So next we have pattern matching. So next we have pattern matching. So here, as you can just read the language, W belongs to ABC. For each x comma y belonging to ABC star, W is ABCBA, ABCABB, preceded and followed by x and y. Okay, so x is nothing but string of A, B, and C's. Y is also a string of A, B, and C. In between we have ABC, ABB. Okay, that means ABC, ABB is a substring. This is the DFSM.
So screen is not
Okay,
visible.
okay, okay. Okay, now it is visible, right? Now I hope it's visible to you. So we discussed this example, okay, for the missing letter language. Next, we are going to discuss for pattern matching. Okay, see here, language is nothing but for the alphabet ABC, where ABC, ABB should be a substring. ABC, ABB should be a substring. So here, this is the DFSM. See how much complicated it is. But if I write the NDFSM, if I write the NDFSM, then see how much simple it is. So ABC, ABB should be substring. That's it. It is preceded by X, which is nothing but string over ABC, which is done by this self loop, which is followed by Y, which is again a string of ABCs, which is done by this. See how much simple the NDFSM is. So if you want to design DFSM, this is the DFSM, which is very complicated. But NDFSM is very simple. You're going to consider only the transitions which are needed. Okay, and also you may have multiple transitions on one state with the same symbol. See, for Q0, there are two transitions which are labeled E. One is from Q0 to Q1, another is from Q0 to Q0. So that is okay in NDFSM. Okay, so you may have multiple transitions with the same label from a single state. Okay, so this is again another complicated language which is designed very easily by using the NDFSM. So I hope this example is clear to you. Okay, just concentrate on NDFSM. Just look at DFSM. DFSM looks very complicated with a lot of transitions, but NDFSM at the other side, it is doing the same work. Okay, it is doing the same work, but it is very simple. Okay. Yes, any doubts in this? Any doubts? Any doubts in this? Yes, please let me know. Any doubts? Any doubts in this? Yes, please let me know. Any doubts in this particular NDFSM? Okay, any doubts? If any doubts, I'll continue. Otherwise, I'm going to stop here. Yes, tell me whether you have any doubts or not. So, okay. Only two people don't have doubts. That means rest of you have lot of doubts, right? Only two of you are without doubts. That means remaining all now three. Okay, 4, 5 members are there. Okay, now Anvit is having doubt. What is your doubt, Anvit? Yes, Anvit, what is your doubt? Yes, Anvit. Yes, which is the previous example? This one or previous to this? Which one? This example? Yes, Anvit, tell me. Okay, this one. This one, right? The pattern matching. Okay. So here, see here, the language is over the alphabet ABC such that W is X, ABC, ABB, Y. What is X and Y? They are nothing but strings which are composed of ABCs by using ABC in any order, any number of times. But in between or somewhere in the string, you must have ABC, ABB, which is nothing but substring. So sequence of ABC is such that if ABC, ABB substring is there in the string, it belongs to the language. Now you concentrate on NDFSM. ABC, ABB, it is there. Means you go to the final state. Then at the beginning you may have X. X is nothing but sequence of ABCs. At the end you may have Y, which is sequence of ABCs. So these two self loops correspond to X and Y. Okay. Is it clear? Is it clear now? Anvit, is this example clear to you now? Yes. Where is the substring? ABC, ABB. Where is it? In your ABC. What is this? ABC, ABC, ABC. ABC. Once again, what is it? ABC, ABB. Yes. So ABC, ABB, if substring is there means it belongs to the language. Okay. Now, what you have to do is, say, let me consider this example itself. Okay. Let's say the example, what is it? ABC, 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 ABB. So first you have ABC, ABC, twice you have ABC, ABC. For that, you need to use this self loop. ABC, ABC is processed in this self loop. Okay. So you guess that. You guess that first two ABCs should be processed by self loop, because first A can be processed either by this or by this. But you guess that first A has to be processed by self loop. So first ABC is processed by self loop. Then for ABC, you follow this path. You reach Q6. Then at the end you have ABC once again. So that is processed by this self loop. That means after processing the entire string, you are in Q6, which is the accepting state. Any doubts now? Any doubts? Anvit? Okay. Anyone else is having the doubts? Anybody else is having the doubts? Both the representations mean the same. Which representation you mean these two, DFSM and NDFSM, right? So both representations are not same. One is deterministic, another one is non-deterministic. So here see, from Q naught, there is only one transition for A. So you have the clear picture, you have the clear cut idea. That is, from Q naught, you must go to Q1. Q naught, you must go to Q1 on input symbol A. But here, there are two possibilities, either to Q1 or to Q naught itself. So there is a non-determinism. You cannot determine clearly whether to follow from Q0 to Q1 or Q0 to Q0 itself. Okay. So both are different representations, but they are representing the same language. Okay. Is it clear? Yes. Any other doubts? Any other doubts? Yes, Prashanti. Any doubts? Prashanti. Yes, Pratiksha, tell me. Previous to this question, which one? This one. What is your doubt in this? Q5 to which question you are? This one only. This question only. Q5 to Q6. What is the doubt? This one, right? Pattern matching. What is the doubt in Q5 to Q6?
No, sir. Previous to that.
This one. Where is Q5 in that? This one.
Before this. Before this.
This
Yes,
one.
this one.
What is your doubt in this?
So Q5 to Q6, that A comma B is there, no, sir.
Yeah.
So I have doubt in that, sir. Like how
Hmm.
that A comma B came. Like
How means, see, there are two possibilities. Either W should be equal to AB. For that, you have this path. Okay, if you follow this path, then W should be equal to ABA. Otherwise, if you follow this path for accepting W, W must be of even length. So Q5 is the accepting state. So even length means sequence of A's and B's are not important. Just their count is important. Okay, so they must be of even number. Okay, so in Q5 you have not read anything. See, epsilon, from Q naught, by reading epsilon you reach Q5. That means you have not consumed any input symbol. That means length is 0 right now. 0 means it belongs to the language. That's why Q5 is the accepting state. then you can have either A or B. One symbol, you get one symbol, you reach Q6. In Q6, length is odd. On next symbol, it can be either A or B, you reach Q5. So 1, 2, length is even. Again, if you have two more, 3, 4, again, length is even in Q5. What's your doubt in this?
So if A comma B is, if it is odd number, then it goes to Q6, sir.
See, in Q5, you have not read anything. So let's say your input is just A. Input is just A. See, uh, let me give an example. AB. Whether AB belongs to the language.
Yes.
Yes. AB because it's of even length. See, for AB you can follow this path also. See, you will follow this path. By reading epsilon, you come to Q1. Then for A, Q1 to Q2. Then for B, from Q2 to Q3. So after that, you don't have anything. You are stuck at Q3, which is rejecting state. Okay, that is one possibility. So for NDFSM, there must be at least one path where your string gets accepted. Now come to this path. So you reach Q5. Your string is AB. For A, you make a transition from Q5 to Q6. Then next symbol is B. For B, you make a transition from Q6 to Q5. That is after processing AB, you are in state Q5, which is the accepting state. So you had two paths. In the one path, you ended at Q3. In the other path, you ended at Q5. So there is at least one path where your string gets accepted. That is nothing but Q5. That's why your string belongs to the language. That is NDFSM. NDFSM means if there is at least one path where your string gets accepted, then string belongs to the language. For AB, we had two paths, one which ended at Q3, one at Q5. But there was one path which ended at accepting state. That means string belongs to the language. Is any doubts now?
Yes, sir. Understood. Thank you, sir.
Okay. Okay. Any other doubts? Yes. Any other doubts? Prashanti? Prashanti, are you there? Any doubts? Okay, so I think that is enough for today. Okay, so you can leave now. Yes, Ibrahim, any doubts? Ibrahim.